little review of algebra, but before I start with that review, I'm just going to go over what the work sample, what kinds of things you're being graded for on the work sample, 5 different areas. And I already, in the other video that I made, geometry, I already mentioned these things. So if you already watched that video, you can just skip over this part right now. But if you have not seen that video, then you could listen to this now, and then if you watch that video later that on geometry, you can skip it over this part at that point. So what you're doing here is you're gonna, first of all, you're gonna be graded on making sense of the problem, which is the what. And what that means is that you turn the word problem into numbers or symbols, and you use mathematics that what actually fits the problem. So you want to make sure whatever formulas or whatever you're going to be using to solve the problem actually makes sense for the problem. So that's pretty natural that you'd want to do that. So then number 2, you're going to be representing and solving the problem, and that's how you do it. How you're solving this problem is you're going to use, again, this is kind of similar, that you're going to use skills and strategies that fit the problem. And you're going to show all of your work. You're going to use, if you need to use a diagram, a picture, a model, a number, or symbols, you're going to show all of that. Show as much as you can. One of the best things you can do when you first start a word problem is draw it out. Draw it in a mathematical way. If you can use a coordinate plane or some kind of graphing to represent the problem, then that's a great way to go about it. You can also, if there's any variables, you start to write down those variables and how they relate to one another. And I'll go over some algebra in a minute here. Number 3 is you want to communicate and reason. You want to show a connecting path. And you don't need to necessarily use words unless you feel like it's necessary. Some people overwrite and over-explain. But if you can explain it mathematically and show a clear path from how you got to the problem to the solution, and you don't have any gaps that I have to figure out what you meant when you went from one step to the other, and it's very clear how you got from one step to the other, then that's great. That's what you want to do. You don't want the reader to have to fill in anything in their minds or as they're looking at it. And you want to make sure your labels are appropriate and accurate. For example, if you're working in square units, stay in square units. Or if you're finding the area of something, you want to be in square units. And you also want to make sure if you're working in inches or feet, you continue to work in inches or feet. If you're working in meters, continue to work in meters. Number 4, accuracy, of course. You want to be accurate and correct. And you want to make sure your answer matches what the problem is asking. You want your final answer to be complete and justifiable. And in order to get even a higher score, the highest score you can get is a 6. You get 1 through 6. You can also extend your work by asking a new question that leads to new problems. So number 5, the last thing is reflect and evaluate, and that's the very, very important one that students sometimes don't spend a lot of time on, and that could actually make it so you don't pass the work sample. And that's your defense. So you want to state the solution in the context of the problem and make sure you have the correct units. You want to show that your interpretation of the problem, your concepts, the concepts of the problem, the strategies, and the calculations that you used were reasonable and accurate. So you want to, every time you're going to double check your work, you want to show all of the double checking you're doing. And if possible, one of the best things to do to get your score up higher is to work the entire problem in a second way, and because there's different ways to solve a problem in math. There's 2 or 3 different ways that will get you to the same solution. So to recap, you want to show your answer and all of your work so everything is clear to the reader. Okay, so let's take a look at some algebra just to remind you of some basic algebra. If you have a graph, a coordinate plane, one thing to remember is if a line is going from left to right, just like you would write, and you always write from left to right, we write this direction. So if you're coming from left to right and you're going up, that's going to be a positive slope. So your number for your slope will be a positive number. And if you remember y equals mx plus b, this number right here, the m, is your slope, and so that number would need to be positive. If you have a negative slope, you're going from the left to the right, like you write, and you're going down, that's a negative slope. And so your slope is going to be a negative number, let's say negative 1/2 x plus b. And so, and if you remember, the slope is the rise over the run. So the rise is your y. Here's your y and here's your x. So how far you go up or down is the rise, and how far you go in this direction is the run. And so if you have, let's go ahead and erase one of these. Let's take a look at a negative one. And so if you have two coordinates here, this one and let's say this one, you're given two coordinates, then that's great. Actually, let's erase this all together so I can show you that if you were given two coordinates, an x and a y and another x and a y, let's say you were given -1, here's 4, let's say, and this is -1, and then so that would be, this right here would be -1, 4, because x is before y in the alphabet, so you can think of it that way. X comes first, that's -1, and 4 is the y coordinate. And then let's say you're given another one over here, and let's say this is a 3 and that's a 1. So that's 3, 1. So now all you need is two coordinates, and then you can make a line. Whoops, it's kind of hard to make this line. Okay, here we go. Pretend like that went through that coordinate there. So you can make a line this way, and all you need is two coordinates, and that is called a linear. This is linear, as opposed to, there's some other times where you're going to get a parabola or a quadratic equation. This one is a linear, it's going to be a linear equation, and so it's going to have this sort of formula here. And again, because the slope is going to be negative, and the way to figure out the slope is it's the change of the y, which is your rise, over your change in x. So in this case, you can take this coordinate here, you'll take your change of y, which is 1 minus 4, because that's a 4 up there, so 1 minus 4 divided by, and you want to start with the same coordinate when you're using the next set of the x's. So if you use this to start with up here, then you're going to use this one to start with up here, or down here. 3 minus -1. And that's going to be 1 minus 4 is -3, and 3, and then minus -1. I always just think of this as you go make that into a plus. So your slope here that you're in wouldn't be the negative half here. It would actually be -3/4 x. And then the b here is wherever it goes through here on the y, but we don't know that, so we can't fill that in right now. We just have, at this point, we have just this right here, this information. So we wouldn't want to use this formula if we actually wanted to come up with our equation, because like I said, we don't know what b is. So there's another equation that we can use for that. But I just want to show you something really quick. Let's say you forgot which one's y2, which one's y1. It's just the change in y over the change in x. So let's say you decided to use this one. We put these the other way around. 4 minus 1 over -1 minus 3. Well, it still works out to be the same thing. You just have to make sure, if you're going to use these guys first, so you got, on this case, you have 4 minus 1. And you'd want to use, since you use 4 first, over here, you'd want to use your -1, your x value first here. So you're going to see that it equals the same thing. 4 minus 1 is 3. -1 minus 3 is -4. So again, that's just -3/4. So you could, on a problem, you could do it both ways just to double check to make sure you got the right slope. But we don't have an equation yet for this. And the reason you want an equation is because you want to be able to, let's say somebody gives you an x value, or you want to know what y would be if x is 10. If x is 10, what would y be? Well, if you have a formula, then you can plug in 10 for x, and then you can find out what y is. But again, since I said, we could guess that this might be a 3, but that's not correct enough. That's not accurate. This could be a 3.1 or a 3.2. So we can't use this formula. Let's look at a different formula that we can use. The formula that we can use is what's called the point slope formula. And it's y minus y1 equals b x minus x1. And the y1 and the x1, if you could just pick one of those coordinates that we were just let's say we were looking at that, and I can't now remember what I wrote here, but let's just make up new ones. So we've got, well, I think it was -1 and 3, was it? And then we'll just make up another one over here. See, it was, do 1 and 1. Let's figure out the slope again real quick, practice that again. So we've got 3 minus 1, the y, 3 minus 1, over -1 minus 1. -1 minus 1. I'm just doing it in that order. So it's going to be 2. -1 minus 1 is -2. So that is just going to be equal to -1, that slope. So b is going to be equal to -1. 3 minus 2, -1 minus -1, -2. And that equals 2 over 2 is 1, and that's negative, because we got one of the numbers was negative. If both of the numbers were negative, then that would cancel out, and that would be a positive number. But another way to double check that is you know that your slope here should be a negative number. So when you do the calculations, if you came up with a positive number, but your line was sloping down like this, you would know you were wrong. And so that's the one thing on your work sample you could use as a double check. If you could say, I know this is, it seems reasonable because my line is a negative line. So the slope being negative, that makes sense. And then for this, you're going to have you want your equation to have a y and an x in it. So these are going to just stay as y and x, because that way then you have a formula and you can plug numbers into it. You don't want to have all just numbers. You need to have the variables in there to have a formula that you can plug numbers into. So any numbers along this line. And so you can pick either one of these coordinates, either this one or this one, for your y and your x. But whichever one you pick, you just use that one only. So let's pick this one. And we're going to do y minus, and then the y is the 3 here. And then we know the b. And then we've got x minus, and then it's going to be this one, -1. You want to do everything in the parentheses first, so let's just change that to a plus. And you want to use the distributive property for this. So you got -1 times x is just simply -x. -1 times 1, which is -1. And then you have y minus 3 over here still. So you want to get it, whenever you have a formula, you want y to be over here. Y equals -x minus, and it's -1, and you're going to add 3 to each side to get rid of this one, plus 3. So y equals -x plus 2. That makes sense because, again, you could say this makes sense because this right here if you go back to this, now you're in this form. You got back to this form again. And this is our B. And it does look like it crosses, because this B always is where the line crosses the y-axis. And so that does look like that could be 2. So now if we needed, like I said, to find out what would y be, and by the way, y is a function of x, so we can also use f of x or whatever we wanted to do. If sometimes people don't use x, they might use, if you're looking at something like the height of something, they might just say, it might say f of h equals negative h plus 2. If you're looking at the cost of something, f of c equals negative c plus 2. I mean, you don't have to use x. So then we want to know, we were just saying, well, what if x is 10? What would y be? Or what would the f of x be? So let's take a look at that. It would be negative 10 plus 2. And so that would be equal to negative 8. So that makes sense, because if you come out, if this is 1 and you come out further to maybe 10 here, you probably would be then at negative 8 down here. The last thing I want to explain about this is what's called the independent and dependent variables. So x is always the x line here, the horizontal line, whether it's x or c or whatever it is, it's always going to be the independent variable. And the y will always be the dependent variable. And all that means is that the independent variable is just fixed. It's not going to change. So an example of that would be, let's say you are looking at a temperature. Oops, let's see here. The temperature of something, that's a dependent variable, because it's depending upon it could be something that has to do with elevation. It could be something to do with like what altitude you're at in the atmosphere. And so your independent variable, let's say you're up in an airplane and you're up at this is the miles above ground you are, 1, 2, 3, 4, and as you go up into the atmosphere, and that's the independent variable, that's just something that's fixed. But your temperature, say this is your temperature in degrees. Your temperature, let's say you're at 100 degrees here on, and this is Fahrenheit, at 0 at sea level. Typically, as you go higher up into the atmosphere, the temperature is going to drop as you go up. The temperature is completely dependent upon how high you are in the atmosphere. The temperature is dependent upon that. So that's why it's a dependent variable. How high you are is not dependent upon anything. You could go, I guess it's dependent on how high your airplane can fly, but that's not part of what we're looking at. Those aren't the variables we're looking at. We're only looking at how high you are based on versus or compared to the temperature. So whenever you're trying to figure out, okay, which one is my independent variable and which is my dependent variable, you always want to think about which one of these depends upon the other. So in this case, like I said, your temperature depends on how high you are. This always is the same thing. The x is always your independent variable, and this here, the run, and the dependent is always this. And it was just chosen that way because that's how the people that began to represent, the mathematicians that started to represent numbers in a graphic form in this way, thought that was the best way to represent it, because again, like I was talking about earlier, you can see by just at a glance if the slope's going down, the kind of relationship you have, it's a -1, or if it's going up, it'll be a +1. So it's just something that mathematicians, they just get used to looking at this and knowing, and just at a glance. And that's what's so cool about graphs and this sort of thing is, and even with equations, what's so is cool about it, well, the graph is cool because you can just look at something at a glance. Once you get the equation, if you have two coordinates, then you come up with an equation, and then you can plug in any number and make some kind of prediction about, let's say on this example, let's say you only have the information for 1 mile and 2 miles in the air, and you're noticing that it's a linear relationship. Well, then you can find out, once you get because you have these two coordinates and you find your equation, then you can figure out, okay, well, what's going on at 3 miles in the air, or 1.5. You can plug that into whatever equation you come up with, the y equals mx plus b, because you figured out using all those steps we just did earlier what the slope is and where it's crossing over the y axis, and then you can plug in an x and you can get y. So this is pretty cool. It's just this is really algebra in a nutshell, and if you understand this concept, you could do well on any basic algebra problem. So hopefully this helps as a little review of algebra.